Hey folks, Tom Casey here today talking to you about the different types of motors. The motors that will be found in your current system versus the motor that will be found in a newer modern system that meets energy efficiency standards. Your old motor is what's called a PSC motor, standing for permanent split capacitor. Very reliable, good old-fashioned technology. But the problem with it is as the filter got dirty or conditions in the system changed and the external static pressure changed, airflow would change. And that resulted in capacity issues, reduced performance, reduced efficiency, things like that. So the government mandated a new efficiency standard a while back, and they want to make sure that the efficiency keeps going up and up and up. So the PSC motor really has a hard time accomplishing that. And so the ECM motor was introduced, and the ECM motor works on a different technology. It uses a program in the motor itself to measure the RPM and the amperage to create an algorithm to find out how much air is moving, so it can always speed up or slow down to maintain constant airflow over a whole wide different set of circumstances that your system could see. And as you can see in this chart here, let's look at this purple line, which represents an ECM motor. And as you can see, when the pressure or the resistance to flow is low, the airflow is high. But as that pressure builds from point 2 to point 4 to point 6 to point 8, as things get dirtier or ducts get older and sag or things start to break down, airflow steadily declines over a period of time. There's a point at which airflow will go below the system minimum that you want to have. Whereas the ECM motor is constant under all pressure conditions, it'll speed up and slow down to maintain constant CFM or constant airflow under any pressure situation. Now this is normally in 8 out of 10 cases an amazingly beneficial thing to you as the homeowner, because rooms that couldn't quite get airflow now get airflow. Ducts that were kind of not as conducive or friendly for airflow perform better. And especially for systems as things got dirty, like filters got dirty or ducts got dirty, and airflow would decrease in an old-fashioned PSC motor. With the new ECM motor, airflow remains constant. So again, about 8 out of 10 times, people just absolutely love it. But one of the possibilities when you go from a PSC motor to an ECM motor is that if you have a marginal duct system, if your ducts were sized on the borderline or possibly sized to use one type of duct material and then use another material like flex duct instead of metal branch runs, then what ends up happening is your old system would likely ride the fan curve, which is basically riding this slanted line downwards and operating at a lower airflow, because as the pressure went up, the resistance to flow went up in the system, the motor would actually slow down because it couldn't spin as fast. Whereas the ECM motor in your new unit is going to speed up and up and up, and so it's going to push that airflow by. And some customers in that 80-20 situation have noticed that the new system is a little louder because it's moving more air than the old system moved. Also, if the duct system is really out of whack and the system operates beyond the chart, or what's called out of range, some other things can start to happen when you go from technology of a PSC motor to an ECM motor. You can get what's known as surging or pulsing, where the fan sort of sounds like it's speeding up and slowing down, speeding up and slowing down. And in fact, that's exactly what it's doing. It's reaching its limit, then scaling back, then reaching its limit, then scaling back, because what is connected to the supply duct or the return duct system is too restrictive for the amount of air we're trying to move. Also, sometimes when you operate outside the range, things become unstable in the sense where the vibration increases a little bit, as well as amperage and heat and things like that. So while this ECM motor, this green line here, is amazing and wonderful benefits for constant airflow and constant capacity and constant efficiency, if you have a marginal duct system and you used to ride this purple slanted curve down and you operated at some point below here, the new system is going to move more air and possibly have some things that require adjusting or getting used to, and in extreme cases might require some modifications to your existing system to make everything work properly. But we'll take care of you in any event. Boom.